So this is the second video on section 1.5 from Precalc 1, which is on slope, and more specifically slope as our average rate of change, or as a rate of change. So slope is the average rate of change, and like I went over in the previous video, we have m is equal to y2 minus y1 divided by x2 minus x1, or sometimes we write this as delta y over delta x, or change in y over change in x. That's what those triangles represent. And I wanted to put up here just real quick, we have sometimes this equation is written in not y1, y2, but like f of x2 minus f of x1 divided by x2 minus x1. So you can see it in both formats, and sometimes you'll be given points and you want to just plug it into the y1, y2. Sometimes you'll be given a function and you want to know the average rate of change between two numbers, and so you're going to plug those numbers into the function, and in that case this f of x2 minus f of x1 makes more sense. I'm going to go through these. These are slides from the previous presentation. Okay. So slope is average rate of change, and I've just written it back up here. Is the slope of a line through 2 points on a graph is the rate of change between those 2 points. Is the change in y per unit x. And so I have an example here where we are given at 2 seconds we're at 20 feet, at 3 seconds we're at 45 feet, and they want to know your average rate of change. So this is very much a time, we have a time point and we have a position at that time point. And again, here this is T2 and we have S of T2. Okay, and so the average rate of change of position is actually our speed or our velocity. So this is oftentimes something, especially like in the when you get into physics and kinetics in physics, it's something that you do quite often. But in this example, we're just given our 2 points. So at 2 seconds, we're at 20 feet. At 3 seconds, we're at 45 feet. And we want to know the average rate of change between 2 and 3 seconds. So what we're going to do is we're just going to use this delta y, delta x, but we'll use it in the format as s of t2 minus s of t1 over t2 minus t1. So it's the same equation, we're just using different symbols in here. So s of t2 is 45 feet, 45. S of T1 was 20 feet. This is feet. T2 was 3 seconds, and our T1 was 2 seconds. So 45 minus 20 is 25, and our units on top were feet, and on bottom is seconds. So we're moving at 25 feet per second between the minutes of 2 and 3. So our position is changing at a rate of 25 feet per second. The other type of problem that we might get is when we have an f of x in here. When we have f of x, we want to find the average rate of change between 2 points. So we have x equals -2 and x equals 0. So we're going to go back to the format of our equation, this delta y. We're going to write this as f of x2 minus f of x1 over x2 minus x1. So f of x2, we need to find f of 0. 0 cubed is 0. And we want to find f of -2. F of -2 is -2 cubed, which is equal to -8. So now if we want to find the average rate of change between those 2 points, now we have everything we need to plug into this equation here. So we have f of x2 was 0 minus f of x1. F of x1 we're going to put this as x1 and x2. F of x2 was -8. So we're minusing a -8, which becomes +8. And our bottom is x1, or x2 is 0, minus x1, minus -2, which becomes +2. So this is 8/2, or 4. So the average rate of change of this graph between -2 and 0, this graph is increasing at a rate of 4 units of 4 per our x unit. I think that's all I had. Yes. So we just want to make sure that we remember the slope is our average rate of change. And whether it's given to us as points, or we're interpreting a graph, or we're given a function and we want to find the rate of change between 2 points, it is the average rate of change between those 2 points. And we can use this equation for slope to figure out what that rate of change is. Okay. Like I said, this is the second video in this sequence, so there was material on parallel and perpendicular lines. If you're struggling with that from this section, there's another video on that, and please check it out.